All right, we're back with part 3. So what does the conditioned stimulus become? There we go. So there have been a variety of theories out there, and I think one of the sort of most basic one that we hear quite frequently is that that of the stimulus substitution hypothesis. In other words, that when you condition, say, bell, food, bell, food, bell, food, that eventually they perceive the bell as being food, that the dog substitutes one stimulus for another so that they respond to the bell like it was food or happened to be food. That there's some kind of now that they've made that association, now that they think that the bell is some just strange form of food. And the answer seems to be is that it's probably not, that animals are a lot smarter than that, and they're not just substituting one stimulus for another. Rather, what they're doing is that they're paying attention to the fact that the CS doesn't substitute for the US, it just tells us that it is coming, and that they engage in preparatory responses towards the CS, like getting ready to start salivating, perhaps maybe a little bit licking, maybe looking at the conditioned stimulus or tracking where it's coming from, so that to be prepared for when that US is about to come soon. So the CS tells information, it tells us something is coming, and it activates sort of biological preparatory responses for that. One of the experiments that kind of highlighted this was done back in 1973, and it was a really cute paper about chick behaviors chicks that snuggle up. So what they did is that they paired a red key stimulus, so that they were in a little box, and when a red key lit up, a couple of seconds later, a heat lamp would turn on to give the chicks a little bit of heat. And for those of you who have been around little chicks, know that when they're young, you need heat lamps around to keep them warm. And it's a biological stimulus. It's an unconditioned stimulus that they respond to. So chicks see the little red light, then it comes up and you start to see a response to the heat lamp. And a sort of a biological chick response or a reflexive response to the heat lamp is to fan your little wings out so that you can essentially absorb as much heat as possible. So if you were just to give them a heat lamp, they would engage in this kind of behavior. So heat lamp and then spread your wings out. So if you were expecting that the animals were coming to perceive that little red circle to be essentially identical to the heat lamp, you would anticipate that you would get Pavlovian responses to the light or to the red key light to be something like this, just like what they would to the lamp. So they start spreading their wings out to the little red key light. And in fact, so this is the sort of wing spreading behavior. And in fact, oops, I went too far. That's not what they do. What they do is they engage in what they call snuggling behavior towards the red key light. So when the red key light turns on, they go up and they move and rub their head up along it. They'll sort of rub their body along it. They might do a little bit of pecking towards it, but you see almost none of this behavior, indicating that they're not perceiving this red light or this red key light to be the same as a heat lamp, but they're perceiving that this sort of red key light is coming into association with it and telling them that this red light is coming on. So they start engaging in preparatory responses like, snuggling up and sort of moving in close, instead of engaging in the actual sort of reflexive response that they would do to the unconditioned stimulus. So what this highlights is that in Pavlovian conditioning, it's not that the animal is coming to perceive this conditioned stimulus like the bell or the red key light or any of these stimulus to be the same as the unconditioned stimulus, just that it is giving us information that the unconditioned stimulus is coming. And then the conditioned responding or sort of preparatory responses to that can vary in a wide variety of ways, but are typically some type of biological preparation for the upcoming stimulus, rather than necessarily treating it as the stimulus itself. So another really important topic is generalization. So generalization refers to responding to different stimuli as the same. So we've been talking so far as stimuli being unitary, right? A metronome doesn't vary. A bell goes bing, and that's it, never changes. But in reality, all of the stimuli that we use are actually going to be different from trial to trial, right? Sometimes when you ring a bell, it'll be at a certain decibel level. Perhaps you ring it at another time and it's a different decibel level. Or perhaps you're using a tone and you have one frequency of tone, and then sometimes you use different frequencies of tones. In other words, it's quite possible that the conditioned stimulus that is being used is going to vary from trial to trial or across experiences. So what happens when this occurs behaviorally? So here's an example of what we call a generalization gradient or respondent generalization. So let's say we were training a tone, and we were training a 1200 hertz tone. Just to make it easy, let's assume 1200 hertz tone sounds like boo, and 800 hertz tone would sound like boo, and a 1600 hertz tone would sound like beep, and then a 2000 would be like beep, really, really high, right? So we have variation of that tone. Some are more similar to others, like if you're closer in hertz frequency, it's going to sound more similar. So what happens in behavior? So if you were to train and Pavlovian condition this tone, but then present a variety of other tones, this is what you see. You see condition responding will decrease as you make the tone more different. So going from boop to boop, boop, to beep, beep, the responding will decrease and sort of drop off. But the more similar it is, you'll actually get pretty decent responding. So the animals will generalize to some range, generally speaking, you know, some hertz up, some hertz down. But as you get further and further away, that generalization will decrease and decrease such that you only see, say, a conditioned response 20% of the time when you get further and further out to these levels of stimuli. There have also been a variety of other kinds of sort of case examples of generalization. If you've been through a general psychology class, you've probably heard of little Albert. So little Albert was a little boy. This was really, a lot of times it's considered an experiment, but in reality, this was probably best described as a demonstration. This was done by John Watson in the 1920s, which today would never really be allowed again. They took an 11-year-old boy, gave him an exposure to a white rat, and then conditioned to fear by basically banging a lot of loud noises once Albert saw the white rat behind him. As you can imagine, whenever little Albert saw this white rat, he became super fearful of that. But not only did he become fearful of a white rat because of its association with the loud noise, he became fearful to a lot of other sort of white and furry objects. So white slippers, a bunny rabbit, anything that also happened to be whitish and also fluffy would produce a fear response in Albert, suggesting that his fear generalized not just to that one sort of conditioning example, but to a variety of other similarly related stimuli. So Albert's fear generalized to anything that was white and furry, including rabbits as well as a Santa Claus mask. So now we've been talking really about one stimulus being paired with one unconditioned stimulus, or one conditioned stimulus to one unconditioned response. We can actually get a lot more complicated types of Pavlovian conditioning going on as well. You can have what's called second order conditioning. Second order conditioning is basically when you have regular Pavlovian conditioning, like we talked about, bell plus food produces salivation, so that the bell eventually just comes to produce salivation. This is first order. This is what we've been talking about. Nothing is different. Second order is going to be if we then pair another stimulus with our conditioned stimulus. So conditioned stimulus 1, or conditioned stimulus 1 is here, conditioned stimulus 2, so CS2 plus CS1, and we just pair this over and over again. Even though we're not presenting any food here, after several pairings of CS2 with CS1, after CS1 has been paired with food, we'll actually see conditioned responding to the flashing light in of itself will produce salivation, even though the flashing light had never been directly paired with food, it was indirectly paired with bell, and bell was paired with food, such that flashing light in of itself will produce our conditioned response of salivation. So every stimulus does not have to be directly paired with the unconditioned stimulus. In the same way, generalization was that we can have variations of the same stimulus produce a response. We can also have stimuli that get paired with the conditioned stimulus can also produce a response. So this is CS2, and this stage is our second order conditioning stage. One question might be is, can you reverse this? Can you do flashing light and bell, and then bell and food, and then get flashing light salivation? And the answer is yes, and this is called sensory preconditioning. So if we're thinking about dogs trained on detection, you can pair odor with toy, and you might get some type of excitement such that the odor itself will generate excitement. That's first order conditioning. And then you can also pair that their training area or training room gets associated with odor, which then gets associated with food, such that the training area itself can engender a very excitement response, even though the training area may not have been directly paired with toy, it had previously been paired with an odor, and the odor has been paired with toy. So in second order conditioning, the subject learns that the CS predicts the US, then a second CS predicts the first CS, such that the CS, the CS2 comes to elicit the unconditioned response, or the conditioned response as well. All right, let's take a break for part 3